welcome to another creative motion video tutorial. This tutorial will be a continuation from our previous wheel rotation techniques Xpresso tutorial. So if you haven't looked at that tutorial, I'd recommend checking that out first, because this is a little bit more advanced, and it's kind of continuing on from where we'd left off there. I'd been asked a couple of questions, and mainly it was around some of the limitations that rig had. So with that rig that we built previously, it could drive rotation based on positional movement, and a simple form of doing that would be to move this control object in one axis, and it rotates this, and it's all calculated based off of the circumference, so we don't get any sliding, and it's kind of true to the movement. So the simplest form was to kind of base it driving just one axis. The other way to do this was to calculate the distance, and that was done by using the current position and the previous position on the previous the current position and the position on the previous keyframe. And with that information, we can calculate the space this is moved over a current keyframe, and that then can drive the rotation of this object. And the good thing about that is it means we can kind of drive the rotation based on any direction, any axis. The limitation that had was it was kind of if we moved it forwards, it would rotate clockwise. If we moved it backwards, it would rotate it up, down. There was no control over which direction this would rotate. So I'm just going to take a quick look at how you can kind of solve that, and how you can kind of feed in some data or read some information from this, just to kind of negate the calculations and rotate the opposite direction. So just let me pop up the doodle tool. Okay, so I've got a doodle paint tool here. I'm just going to really quickly just go over what we're doing here. So we'll have the previous position, we'll have the current position here. Okay, so what we need to do is we need to work out if the previous position, say, is greater than the current position, and if it is greater than, then we output a value of 1, which is like a Boolean value, and you can see that here. So this compare node here is using it's looking at this position, and it's seeing if that position is less than that position. Okay, and if it is, it outputs a Boolean value of 1, which goes into this condition node here. And you can find these two nodes if you right click, go to Xpresso, Logic, you got compare and condition nodes there. Okay, so in one state, let's say we're kind of moving this in a positive direction, moving it this way. It means that that position value here will always be greater than the previous position. If we move it in the opposite direction, it means it swaps things around. So we get a different result out of this. So when it's compared, if it's moving the opposite direction, we'll get a 0 out of this. So by having that kind of Boolean control, it means we can feed that obviously into this condition, and this acts like a switch, and this will switch in two different inputs. I don't think it's, yeah, okay, so yeah, it's currently disconnected there, but you can feed in two different inputs into this. So one of the inputs would be our current setup into input 1, and that would be what we'd previously set up in the previous tutorial. So if this receives a Boolean value, so meaning that it's been pushed in the opposite direction, this condition node here will switch to this negate option here, so it'll allow this route to kind of flow through this rather than the previous one that we'd set up. And that means that with this negate one node flow set up, that'll just reverse the rotation. So meaning that, if we move in one direction, we rotate this way. If we move in the opposite direction, we rotate the other way. So that's one way of setting up this process, or one way to kind of overcome that problem. Okay. I mean, practically, if you'd really use that, you might only need to kind of rotate and move this around like in limited directions. In reality, if you had something fairly complex, this would probably be following a spline. So if that's the case, then this method no longer works, because if we are following a spline, then we can't really read out these position values, because it's just not output. The data is not kind of outputted from the controller anymore. So we'll look at other ways of doing this, and we'll also look at like some additional control as well. So if I flip over to this other scene here and just play this, now you can see we've got our own custom kind of align to spline set up here. So I've got the wheel rotating around, and the way this works, it's kind of everything's calculated based on the length of the spline. So if we extend, our kind of animation path longer, this is not going to mess up. Everything's going to be kind of parametric, and everything will kind of update based on the length and the distance of this. So, and the next thing that we have set up is, you can see we kind of got that twisting effect, and we'll take a look at how we can calculate that. So you can see currently it's not working in reverse, but we could add some additional Xpresso just to kind of flip that around, like we've previously mentioned, with the rotation of the wheel backwards and forwards. You could apply the same principle to kind of to eliminate that, or flip it to the opposite side as we move backwards. With this object being aligned to the spline, it means that we don't have to kind of, because it's being generated from a 0 to 100% value. As we move up, it drives it forwards. As we pull it back, it drives back. That's quite simple, and that kind of works on its own. So we don't really have to worry about that when we've linked this to a spline. One of the difficult things to work out with this is how we then can kind of drive, the rotation of this based on what the curvature of the spline. And we'll take a quick look at how we can do that. So I'll just play this through once more. So you can see how that's kind of automated around. So let's take a look at the Xpresso. This is fairly messy here. You can see, I mean, for the purpose of doing this, I could have used some more formula nodes instead of using too many math nodes, but it helps explain the process just a little bit easier. So the first thing here is we have our spline. Okay, so it's essentially this object here. That then gets pulled into a spline node. And XP here is user data, and then that's just a simple slider that I've placed on this null. So everything's basically driven from this user data from 0 to 100. So the movement along the spline, the orientation, and also the banking is all driven just by this value here. Okay, so one of the cool things here is from this spline we can output, we have this length value here. So with the length we can calculate So essentially we know the length of the total length of the spline. Okay, so if we know the total length of the spline, and we can calculate the circumference, so we've got obviously this length here, and using pi we can calculate the circumference of this. So then all we need to do is divide, that length, kind of, going around this, into this length. And I think like at the moment that it works out like 1.4 something, but then we can use that value to keep everything parametric, and that value then gets driven into, find it. Okay, yeah. So essentially it gets driven into this calculation here. So we've got the wheel radius, so let me just quickly draw this out. So we've got the radius of the wheel, and then using pi we're working out the circumference of it using this formula node here, and then what we're doing is we're dividing the result of that by the length of the spline. So that essentially what that's doing is telling us how many times, so you can imagine that we've got the circumference here, is like how many times, if you was to unfold the circumference onto this total length of the spline, how many times can we fit that onto this? And with this unfolded, it kind of works. It reaches to about, like, say here. So I think the value is like 1.4 something, and that then keeps this parametric. So essentially we can work out, if we change the length of the spline, everything updates. Okay, so that's generally that part of the calculation, like where we've got everything in green, say to that point. So all these nodes here, and generally these ones. Let's delete some of these random nodes. So to link the object to the actual spline is quite easy. So we've got object linked to object on the spline node, and then position here. That's then linked to the position, of the control. So that sorts our position to kind of rotate. All we need to do then is the user data drives the offset, so that drives the object along the spline, which is cool. That's what we want. But then the tangent here is where we orientate along, the path of the spline and keep this pointing in the right direction as it goes around. And that currently is a vector. So, I mean, one of the easy ways to kind of find out, what kind of data type you're working with, is just hover your pointer just over, and you can see. If you're trying to connect things up and they're not working out, then just hover over it, and that'll usually kind of problem solves a lot of things. So you can see here we've used this vector to matrix, and what this will do, this will break out the vector, obviously into a matrix format, and it means we can also use this other node as well. So by using this setup, these two nodes here, we can pull out these H, P, and B here. So these are rotational values that then can drive whatever we need to drive. So you can see it's driving the rotation H of the control object. So as so working out essentially the tangent of the spline as the object moves around, and then that's just linking to the control object just to orientate this, in the correct direction as it goes around. And that's fairly simple in itself. I guess the tricky bit really is how we calculate this to kind of bank over and to bank in the correct kind of direction as well as it goes round. And we can do that. Okay, so using this method of if we align to spline using Xpresso, we have a lot more control over a lot of the values. They're not locked out, and we can access a lot more of the data. So what we've got here is, if we take a look at this, we need to kind of look at like what is changing as this goes round. So we know we get a rotation from the control object at this point, and this rotation will be obviously just generally happening just as it goes around each one of the bends. And as before, when we've looked at the situation where we've had a position on one keyframe and we can pull out the data from the previous position, we can generally work out how much how much data is changed over the space of a single keyframe. And from along this section here, say as it drives up the straight section, there's going to be very little change in the rotation of this, and it's only really going to happen kind of as it goes round here. So between say maybe a keyframe here and a keyframe here, we'll get kind of quite a dramatic change in the rotation value of this, but between say here and here it'll be very little. And this change here can drive the banking rotation and kind of get it to revert back. So what we want is to stay in a neutral position when there's minimal change, but then as it's quite extreme between the two, as the data changes quite a lot between the keyframes, we want it to kind of bank more. So one of the ways we can do that is we can use the memory node. Now that works in a similar way of using it works in a similar way to using previous position. So essentially we have a value being read out here, and this value gets sent straight across to this math node just over here, so directly into this math node, and we also have a version that goes into the memory node. Now if we pull out the result on each one of these outputs, I'll do that now just quickly. Just copy this. So you can see as it's banking around, these values are slightly different, but then if we go back here and it's on the straight section, they become a lot more similar in value. So there is some, but that's because there's some very slight rotation going around. And essentially, what this is the value from the current keyframe. And this value here is a value from the previous keyframe. Now, if we divide these two, you can see we get this value. We get this result here. And let's just play this through and just zoom right in here. And if you just keep an eye on this value, so you can see what's happening. Okay, so you can see as this fairly kind of going across the straight section, keep an eye on the value, it's changing very slightly away from 1. But as we go round, you can see it drop into like 0.8, and again, as it straightens up again, we're going back to 1 here, and then the same thing happens, and it repeats every time it goes around. And that's really good, because that gives us enough data to kind of drive whatever we need from this. But what we've done here is not base it just off of values changing slightly below 1 and above 1. We want to kind of start off at 0. So what we're working off here is, like, from this math node here, we bring the kind of stationary default point at 0, and then kind of, as you can see, as it's increasing here, maybe to like not slightly, so we go to 0, and then might we go to like 0.1 that end, or in a positive direction it might be go minus 0.1. Right, you kind of get the idea. So we've got this. So essentially we've got that range to work with. So with that, we know we can kind of drive this and these values in this range, which is very small, and if we plug this directly into the rotation, you hardly see anything happening. But we can map those results. So that then gets linked into Range Mapper. And you can see down here, we've got those input lower and input upper values. So that range there, this range, is the input range of the Range Mapper. And then with the output range, we can control like how dramatic the effect is. So at this point where I've got like minus 0.2 and 0.2 is a fairly kind of comfortable range for me to kind of work at. The higher this goes, the more extreme; the lower this goes, the less extreme the banking effect will be. But with this, you can see that's then driving this effect as we go through. So if you had lots of kind of complex, say it could be an animation or anything, like a wheel rolling around on its own, and you want to kind of automate the banking effect, and you had some complex, really complex like spline shapes, this rig would work for that. So hopefully you've learnt like a few techniques in here. So we've looked at using the memory node, to kind of just based on like one vector or one data value that's coming out, and we can work off reading previous values to calculate how much things are changing over time, and that's really useful, and you can apply that to so many different things. And we're also looked at like how we can negate as well, based on some of the Xpresso that we discussed before. So I hope you found this useful. I'll post a link to the previous tutorial, and thanks for watching. I'll see you in the next one.